All right, everyone, I think I'll just do a bit of an introduction here. So to start off, everyone will be muted and have their video off just to avoid any issues there. And I'll welcome everyone to our third presentation of the Resilient Homes, Parks, and People speaker series. During the presentation, if you have any questions that come up, please enter them into the chat function, and then at the end I'll read them off to Dr. Wang, and we can have that discussion at the end. But yeah, we'll get started now, and I'll just give a brief introduction. Dr. Xander Wang is the Interim Associate Dean for the School of Climate Change and Adaptation at UPEI. He joined UPEI as a tenure-track assistant professor in July of 2018. Before that, he worked as a tenure-track assistant professor at the School of Geoscience at the University of Louisiana at Lafayette in the US. Dr. Xander Wang has over 10 years of teaching and research experience in climate change modeling, hydrological modeling, flood risk assessment, and climate change impact assessment. He has published over 60 peer-reviewed publications in the top-tier journals in climate research, such as the Journal of Climate Dynamics, the Journal of Geophysical Research, Atmospheres, and many more. Dr. Wang is also the developer of and the maintainer of many climate software tools, such as the Canada Climate Change Data Portal, PEI Climate and Weather App, PEI Storm Surge Early Warning System, and the PEI Climate Diary. These tools have been widely used and acknowledged by academia, municipal and provincial agencies, non-government agencies, and the private sectors all across the world. So with that impressive list of qualifications and experience, I'll hand it over to Dr. Wang to begin his presentation.
Thank you so much, Alistair. So today I'm going to talk about something related to climate change and mostly about flooding risks in Prince Edward Island. And this is my email address. If you have any questions, if you want to reach out to me later on, you can email me directly at any time. Okay. So this is the agenda for today's presentation. Basically, I will first talk about some key concepts or general idea about flooding risks, and we will cover overland and also cost of flooding. And then I will talk about some potential impacts from climate change on flooding risks in PEI. Then I will give you some demos to basically help you understand how to estimate the potential flooding risk of your own property. And the whole presentation will be about 40 minutes, and after that we will have some time for questions. Okay, so floods. When we talk about floods, it's basically about a lot of water. So essentially, when we try to understand floods, it's mainly about where the water will flow. So there's an old saying in China, which is man struggles upwards and water flows downwards. So it's quite easy for us to imagine where the water flow, right? So it's basically downwards. And this determines where the water flows. It's basically will flow into low-lying areas. So that means if you are living in some low-lying areas, you are very likely to be flooded. During heavy rainfall events, you probably need to plan for the potential flooding risks. And let's look at this example. Here, I'm going to show you a very, very simple example. Let's use this as a landscape. And imagine that we have 3 properties, 2 uphills and 1 downhills. And then assume that we have intensive rainfall event. So that means we receive a lot of water during a very short time of period. And when the rainfall reaches the surface, and if it is in urban area, we know that most of the urban areas are covered by impermeable surfaces. So that means the water will immediately become as a surface runoff, and then they will flow along with the landscape. So we mentioned that the water will flow downwards. So basically, they will flow into the downhills. So that means the property, at this area will certainly be flooded if we during a very heavy rainfall event. This is because this property is sitting apparently in the low-lying areas, and this is quite easy for us to understand. But let's just put this into a bigger domain. And again, here let's assume that we have a larger area. And just for your reference, here I use this line to indicate the previous case, but we are going to consider a large area. So in this large area, we have more properties, and specifically here we have another property, and also this side we have one more. And again, assume that we have heavy rainfall event, then we have a lot of water falls into the surface, and then we know that the surface runoff flow will typically flow into the low-lying area. And apparently, if we focus on this domain, this property, which is we use B to indicate this property, and apparently because it is sitting in the lowest area, so therefore most of the water will certainly flow into this area. So that means the property B certainly will be flooded. But what about property A? So previously we say A will be flooded, but in this case, if you simply use the philosophy that is a low-lying area will be flooded, then if you compare your property to property A to B, and then you will see it's not low-lying, right? It's absolutely still uphill, but it is at a locally low-lying area. But in this case, you will see certainly A will probably be flooded because it's still, even though A is certainly higher than B, but it is still locally low-lying area, so it will be flooded. And if you think some more complicated cases like this property, and in some cases it can also be flooded because if we have more water coming from the upstream from this property or even uphills, and then this low-lying area will be quickly filled out. Then you will have more water coming from this low-lying area. Then you will be that means this property will be probably flushed out into downhill area. So therefore, there will be it's actually more complicated than we can imagine. So that's why we really need to use some complicated, or we shouldn't say complicated. It's more about a systematical modeling approach to help model this kind of or simulate this kind of simulation so that we know where will be flooded. So that's why we have tried to develop some urban flood model to help address this issue. But today I'm not going to talk about the details about this model. I just want to give you some sense about what we can do with this model. And we know that in urban areas, and we have this urban drainage system, which is underneath the roads. And most of the surface areas are just covered by impermeable materials. So that means we really need to make use of the drainage system to help us mitigate flooding risk. But we know that the drainage system is designed with a certain capacity. If the rainfall event is just bringing too much water, then we can accommodate with the existing drainage system. That means this area will certainly be flooded. So our model can certainly deal with this kind of situation by using the capacity, design capacity for the drainage system. And we have used this model to simulate the 2006 flooding in Lafayette, in Louisiana, Lafayette. And we have run the model for several spatial resolutions from 1 kilometer to 500 meters, 100 meters to 50 meters. Then we compare the simulated results from the model to the observed flooding areas. Here you can see at the bottom, this is observed flooding area. So you can see when we increase the resolution, the simulation results can, reasonably simulate the flooding pattern, basically the flooding extent in this specific event. And another issue for urban flooding is that if you think about some area which are flat, and then sometimes if we have heavy rainfall event, you will probably see in some rivers the stream flow will be reversed because maybe the downstream area mostly covered by impermeable surfaces. That means the surface runoff will immediately flow into the river, and it will raise up the downstream water level. Then it will lead to reversed flow in the river. And this happens a lot in Lafayette, Louisiana, because that area is quite flat, and there's no model can simulate this kind of situation because most of model basically assume that the water will flow downstream. They will use existing elevation data to determine where the water flow. But at certain point, if the water flows reversed, they cannot simulate that. But our model is able to simulate this situation. And for city of Charlottetown, we have an ongoing research project, and we're trying to evaluate the flood risk for the city of Charlottetown. But unfortunately, because this is still ongoing, and I will not be able to share any results with you at this moment. But hopefully, by the end of this summer, we will be able to share some results with you. And while we're waiting for a more sophisticated flood model to do systematic assessment for the flooding risk, we can also use some basic general principle to understand where it's likely to be flooded. And this is again the low-lying areas. And basically, when we determine if it is a low or low-lying area, then we use the elevation to help measure that. And in order to give you a sense, here I'm showing you the digital elevation model map for Prince Edward Island. And here this resolution for the map is 30 meters. And you can see we have some highlands, but generally speaking, the spatial variation of the elevation is not that significant. We can see here the highest point is probably only about 140 meters. But this is based on 30 meters resolution DM data. If we use high resolution, let's say 1 meter data, then you will see this value might change a little bit. But anyway, this is just to give a sense where is low lying, where is relatively high lands across PEI. And furthermore, this is the DM map for city of Charlottetown. And here you can see we use the blue color to indicate the low-lying area, and the red color means the relatively high lands. And generally speaking, we know that these areas certainly will have higher flooding risk because all the water, especially during a heavy rainfall event, all water will flow downstream or downwards. So this low-lying area will be likely to be filled with water. But again, still we need to use some systematical flood models to simulate where will be flooded, like which property will be flooded, something like that. Okay, so in PEI, we are actually facing two types of flooding risk. One is overland flood, and we use this water flows downwards philosophy to determine where the flooding risk in terms of overland floods. because basically we assume water flows downwards. And this is usually applicable when we have some heavy rainfall events, because the water will flow downhills and those low-lying areas are likely to be flooded. But we really need some flood models to simulate the whole area. And another flood risk we are facing is certainly coastal flooding. And in this case, you will notice that the water will actually not flow downwards. It will flow backwards or upwards, because the sea level will be raised up, then it will flow back to a stream or to rivers. So you will see the water will flow upwards. Or we can say the flow direction will be reversed. So this is typically caused by storm surge plus sea level rise. And apparently for personal properties, the distance to the ocean is certainly another factor to be considered in addition to the low-lying area determination. And so that generally speaking, if you your property is sitting on a low-lying area and it is also close to the ocean or close to the shoreline, that means you will have a higher risk of coastal flooding. Okay, so next let's talk about climate change. So basically, how climate change is affecting flooding risks. And one typical way to explain how climate change is affecting flooding risk is that the global warming, the warming temperature, is actually intensifying the hydrological cycle. Here you can look at this image. Basically, when we have higher temperature, then we will have more water will be evaporated into the atmosphere. Then the water vapor will, when the water vapor moves up, the temperature will drops down. Then they will become into water drops, and they will fall into the land surface as rainfall in summer, and in winter it will become snowfall. So this is the precipitation. So you can see this is basically the the hydrological cycle. Because the warming temperature, this cycle will be certainly intensified. So that's why within the context of global warming, we're likely to see more intense precipitation events. Then we will see more flooding across the globe, because especially for those areas which are close to larger water bodies, and this kind of hydrological cycle will be further intensified. And certainly in Charlottetown, we have experienced some this kind of heavy rainfall events, like in August 10th, 2018, and during a very short time period, we have a lot of water rainfall just poured into the surface, and then this led to flooding in most of the areas in the city of Charlottetown. And in addition to the extreme precipitation event or rainfall event, we are also facing other challenges caused by climate change. And one big issue is about sea level rise, and associated with sea level rise, we have coastal flooding, and we also have erosion, and also storm surge. So these factors will, even further, intensify increase the potential flooding risks for personal properties or public infrastructure across PEI. And the reason that why should we care about climate change? The reason is because it is affecting everyone. And you can imagine your own property. Every property is linked to, let's say, the stormwater or drainage system. And during a heavy rainfall event, if the water coming from this event is exceeding the maximum capacity of the drainage system, that means the water will probably back up to your basement, or the surface area will be flooded. The reason that but that's one issue with this drainage system is that when we design these engineering projects, we use an assumption of stationarity. That means we basically use the observational weather data from stations for city of Charlotte. We probably use the station in the Charlotte airport. And we assume that the historical observations will not change in terms of weather conditions will not change in the future. But within the context of climate change, this assumption of stationarity is certainly, will not hold in the future because we see the temperature is changing and the precipitation pattern is changing. So that means, but we still use the historical data to help design our engineering projects. This will certainly bring a lot of issues when we move into in the future. We are likely to see more changes to our climate. And here I'm going to show you an animation about the global warming for the past over the past century. And this animation is created by the U.S. NASA, and basically they will use the data between 1951 to 1980 as a reference. And if it is cooler than this period, then we use a blue color. If it is warmer than this period, we use a red color. So I'm going to play this animation so that you can see as we move forward from 1880 to 2015, what happened with the global temperature. So you can see as we move forward, if you can pay attention to the North Hemisphere, because this is where we are located, then you can see the color is getting warmer and warmer. So and if you look at the final stage, and you will see the red area is pretty much located in the North Hemisphere, like in Canada, Russia, Greenland. And that means the warming in these regions are actually, maybe, twice or even third time higher than other areas, near to the equator. So that means we are experiencing more warming than other areas. And because of this warming, and we are facing some serious issues like melting glaciers and ice sheets. Like here, if you have traveled to the Banff National Park or Jasper National Park in Alberta, you will see this retreating Athabasca Glacier, and they will use not each year, but you will see these labels where this is where the glacier was located previously, and you can see it's retreated significantly over the past century, and also you will see many reporting about the melting Greenland ice sheet, and these melting glaciers and ice sheet they basically will be turning into water, and the water will eventually flow into the ocean, and that means the sea level will be raised up because of these melting glaciers and ice sheets. And so that's why we are seeing some real effects in Charlotte. Here, this is the data I have pulled out from the Charlotte Harbor, and this is the measured tide or water level for the past century. And this is, in this plot, I'm showing you the monthly average sea level from 1912 to 2020. And you can see it is apparent that we are seeing a very significant increase in trends. And if you look at R-squared value, it is more than 0.6. That means this trend is very significant. And here we also have this trend. If we use this number to do a simple calculation, and this means each month we will have an average increase by 0.2 or 0.3 millimeters increase in terms of the sea level rise. If you look at this as a short period, like 1 month or 5 years, it's probably not too much. But if you look at this whole period, and for example, if you multiply this trend by 100 years and then 12 months, and you will get this value. This is about 33 centimeters over 100 years. And this is only for what we have seen based on the monitoring data. But looking into the future, there are so many uncertainties. And we are very likely to see, intensified melting for the glaciers or ice sheet. That means this trend might increase, significantly. So that means the sea level rise might be doubled or even tripled. So that means it's likely that we will expect, 1 meters increase in terms of our sea level by the end of this century. So there are so many uncertainties, but this is what we have seen for the past century. Okay, so next I'm going to give you some, I will introduce some public tools that you can use to estimate or understand the flooding risks for your own property. And certainly there are so many public tools, you can use them. And I will give you some presentation about these tools first, and then I will do some live demo after this presentation. And basically we can simply use, the philosophy that water flows downwards to basically understand if your property is likely to be flooded or not. And so this philosophy is based on the elevation. So that is, so in order to determine the flooding risk, you can simply measure the elevation. And there are so many tools you can use to measure the elevation of your own property. And we can use the Google Earth, and there's a web version, there's a desktop version. If you only need to check the elevation, you can use the web version. And I'm going to show you later on how to use that. And if you have your smartphone, and you can also use the app, like in iPhone, there's a compass. You can turn that on, and you will easily see there's a value showing the elevation for your current location. So you can also use this value to estimate the elevation of your this app to estimate the elevation of your own property. And the means of meaning of this elevation value means how much the land is above the mean sea level. So if it is 20 meters, then that means it is above the mean sea level by 20 meters. And if the sea level rise, sea level is likely to increase by 1 meters, so that means you are still far from the sea level is still far from reaching your own property. But this is just some very simple estimation. But we also need to consider the distance of your own property to the ocean, to the shoreline, and also certain other factors needs to be considered if you want to do a more accurate assessment. And we also have developed a web-based sea level rise simulator to help you understand the sea level rise impacts. If we see like 1 meter or 2 meters increase in terms of sea level, what will happen with local areas? So we'll also give you a demo about this app. And in addition, we have developed some local apps for PEI. One is called PEI Weather and Climate App, and this is its official website. You can use your smartphone or tablet or laptop or desktop computer to visit this app. And this is just a screenshot of the homepage of the app. Basically, you can check the real-time weather information across PEI. We have about 60 real-time weather stations, and you can check so many information about the current weather conditions, like temperature, precipitation, wind speed, wind gust, humidity, dew point, pressure, solar radiation, or even UV. And you can also look at each individual station to explore the past day or past week or even past 30 days observations to help you understand the recent weather conditions. And we also include some links to the weather cameras so that you can get a sense about the current visualization of the weather condition across PEI. And through this app, you can also explore historical climate for PEI. And because when we talk about climate, we usually talk about 30 years of weather observations or even longer period. So, but for most of the stations, we don't have enough records for us to calculate 30 years statistics. So that's why at this moment, we only consider 3 stations from Environment and Climate Change Canada to help users to explore the historical climate in PEI. And another app we have is called the PEI Storm Surge Early Warning System. And again, this is its official website, and this is its homepage. And at this moment, we have 7 real-time tide gauge station installed across PEI, and we have some real-time measurement about water level, and we also have an option that is to send out some warning messages for certain station, and if the water is too close to the harbor, especially when the distance is less than 50 centimeters, we will send out a warning message. So that means you probably want to consider avoiding going to this area because it is likely to experience a storm surge. Then this area is probably likely to be flooded. And there's a function that you can select which site you want to receive the early warning messages, and you can choose all of them. You can also select just a part of the all stations. Okay, so this is the presentation. So I'm going to switch to my web browser to give you just a brief demo about those apps I have shared with you. And just share my web browser. So hopefully you can see my browser. And the first one, at this moment, you are seeing the web version of Google Earth. And you can simply just Google that, just type Google Earth, you can easily find that. And basically here I'm showing you the satellite image, the aerial images of for the city of Charlottetown. And if you move your mouse to somewhere, and if you look at the bottom here, and you can see this is the this is basically the latitude and longitude, and also you have the value. This value is actually the elevation. So for example, you can simply zoom in and just pick up, let's say, let me pick up some area in, area in just a point within the UPI campus, and maybe just this point. If you move your mouse here, you will see it's, if you look at it here, it's 23 or 22 meters. Maybe this value is not that accurate, but it is still good enough for you to get a sense about the elevation of this point. And you can also, based on the map and your distance to the ocean, you can get a sense about the potential cost of flooding risks, like sea level rise or storm surge. If your elevation is 20 or 30 meters, basically you don't need to worry about the cost of flooding. But if it is 2 or 3 meters above the mean sea level, that means you probably need to worry about that, because during a storm surge, the wave, the height of the wave might be 2 or 3 meters in some locations. Then this area certainly will be flooded. Okay, so anyway, this is just one app, one public tool you can use. And the second tool I'm showing you at this moment is is the app I have developed, but this is just an offline app. It is not opened to the public at this moment because it is still under development. The reason is one issue is that we are using just a 30-meter digital elevation data. That means the spatial resolution of this map is not that high compared to the aerial images. And so once everything is tested, later on probably we will share this with the public through our PEI-climate.ca website. But anyway, here I'm going to give you a demo about how this map can be used to help you understand the cost of flooding risks. And here you can see we can simply increase the sea level rise, from 1 meter, 2 meter, or 3 meter, and then you can zoom into this area to see where is likely to be underwater. You can zoom out, and you can also go explore the flooding risk for many areas. And this app can actually be used for the whole globe, and you can also explore other areas. And but one issue is that if I zoom in, to a very, very small area, then you will see the map will the flooding map will be disappeared because our resolution is still too coarse to cover some local areas. But if you zoom out a little bit, you will see the flooding map. Okay, so this is the second one. The third one is this one, the PEI Weather and Climate. And here you can see, this is a current, and just refresh it. I guess this is a current temperature across PEI. And we have many stations. You can zoom in, zoom out. And here, this is the airport station. This is one station in Charlottetown area. You can see its temperature, precipitation rate, wind speed, wind gust, humidity, dew point, pressure, solar radiation. And you can also click on this individual station, click on more, then you will be redirected to a detailed web page where you can explore the past day, past week, and past 30 days information about this station. And you can also download the data. But if you need to download data, you need to register an account first, and then you can download data directly. And also we have this, here you can see we have this weather camera. You can click on this web page. You can see the current road cameras across PEI, and this can help you get a sense about what the weather looks like at this moment. And go back to here. And you can also switch to climate. Currently, you are seeing weather. You can switch from temperature to precipitation and to wind speed, and then to dew point. This is humidity, and then to dew point. And if you can also switch to climate, and you will see we only have 3 stations because we need to use long-term observations. And this is certainly the point, the station in Charlottetown Airport. You can also check the historical climate, like for a certain period, and you can change your already setting. If you want to change this to maybe this month, this is May, you can actually, here you can see a small arrow, click on this arrow, then you will see some options. You can explore temperature, precipitation, or wind. You can also change the average option, like from annual to winter, spring, summer, and then to January to December. So let's look at May. And let's just use this period, but you can change the start year and the end year. But let's just use this period. You click OK, then you will see during this period for May, for this month, and the average temperature is 9.5 degrees Celsius. And the average monthly precipitation for May is about 100 millimeters. And we do have a small amount of snowfall, but mostly will be rainfall. And we also have the average wind speed for this period in terms of the months of May. Okay, so this is how do you explore this app, and you can switch back to weather if you want, and also you can change the base map from terrain to dark gray or streets or even imagery. For some of you, if you want to explore the imagery, area image, you can just switch to imagery, and you can see that. Okay, so this is Weather and Climate App. The last one, this is the PEI Storm Surge Early Warning System. And you can see on this homepage, we have 7 live stations. And we have one in Tignish. This is Lennox Island, Summerside, Northwest Go. And this is, let me see, yeah, Red Hat. And this one is North Lake and Surrey. And you can let's say Northwest Go. You can also check the current measured water level and also how much water is below the top of the wharf. Currently, it is below the top of the wharf by 2 meters. So that means we're totally fine. And here you can also explore the past day, past weekend, past 30-day observations. And this indicates the top of the wharf, and this is the current water level. So you can visualize the changes over the past week or past 30 days. And scroll down, you will see where our station is installed, and this is basically the information about each station. And you can also here you can also change the setting, and here you can see if I change my setting, I can change which station I want to receive early warning messages. And basically, if you want to receive some message, warning message, you need to register an account first. Then you will be able to change this setting to select which station you want to receive the early warning messages. All right, I think that's all the public tools I want to share with you. And that also ends my presentation. So I'm going to stop sharing my screen, and so that we can have the question session.
Okay, if anyone has any questions, we currently don't have any questions as we went through the presentation, but if anyone has anything they'd like to ask Dr. Wang, they could enter it into the chat and I'll read it out to him. But yeah, I think it's definitely a very interesting presentation, and those are some very interesting tools. I'm excited for when the flood level 1 is going to be ready for us to kind of explore. But besides that, for the ones that are publicly available, I think I was planning on sending out a link to the recording once we have it live on our YouTube page. So I can include the links to those tools along with that in an email. And for those of you, I'll send it out to everyone who registered, and hopefully people who were unable to make the talk tonight are able to check it out. Or if you came in a bit later, you can also check out the beginning and catch up on what you missed. Oh, here we go. Do you know about any Charlottetown infrastructure projects to mitigate flooding and sea level risk? Do you have any projects on the go there at UPEI?
Well, for UPEI, we don't have any ongoing projects at this moment, but I do know the provincial government, they do have a test site in Surrey Causeway. And basically, we just put the red rock we have in island in a certain area to break down the wave, the energy from the ocean, so that we can protect well, I guess this is more about protecting the causeway from erosion. but it can also somehow, I guess, can help flooding. But it's because it's just a small area. I don't think it will help help mitigating the flooding from large area. But for certainly might be helping, I think. But certainly there's so much need to do to deal with this sea level rise across the island. This is something that I think we will pursue in the near future by doing some research to, in terms of how to adapt to this kind of increasing flooding risk across PEI.
Definitely, and I can speak to some more on the city side, obviously, being such a low-lying city, as you can see in your demonstration there, a lot of the downtown is almost less than 5 meters above sea level rise, so it is very an important issue for us as a municipality. So there's definitely a lot we're working on as from a public works standpoint. I could mention one project that I'm involved with. We are working with a group of different stakeholders, so including the main lead on it is the PEI Watershed Alliance, as well as us, the city of Charlottetown, the city of Stratford. We have some provincial support, and as well as the Lennox First Nation. So up by Lennox Island, they're going to be doing a oyster reef installation. I guess more as a wider explanation, this project is going to be using living shoreline techniques as a way to mitigate erosion and help deal with those increasing sea level rise. So the oyster reef up in Lennox Island uses almost, I'm not quite sure, I'm not involved in that, obviously, because I work with the city, but usually it uses these structures that inhibit oyster growth, and they can help with the waves coming in and helping to calm or prevent the erosion force of the waves before it hits the shore. In Charlottetown, we are currently working on finding 2 sites to do living shoreline installations, or green shores they're called, and it's one of the center in BC that kind of comes up with the standards for these green shores. So there's a certain amount of points you can do by, not using harder infrastructure, but replacing it with banking, grading, and using different sediments, using vegetation, using dead logs, and just tackling the forces of the waves and the ocean in a more natural way, as we intended, as nature would naturally in some areas. Obviously, with this, so there's certain areas that will naturally erode and build up sediment in other areas. So it's a very interesting technique to help deal with it, rather than just building seawalls and like gabions and riffraff to deal with sea level rise and erosion, which can often lead to other issues. So it's certainly with the downtown especially, it's something where the city is looking into, and they have had a report based on sea level rise and that done a few years ago. So it's certainly something we're considering, but we have a few more questions, so I'll move on to those. Is there any existing stormwater pipe drainage network systems in the city of Charlottetown? Yeah, so a lot of, we do have stormwater systems completely now separated from the sanitary system. In the past, it was more common practice to combine both the sanitary sewer and storm sewer, which leads to a lot of issues when you have the rain going into the combined system, and then you have to, when it reaches a peak that you can handle, you have to dump the water, which used to contain sewage, but fortunately now they're completely separated. So we do have a separated storm system that services the city. I answered that one for you, but here you go, one for you, Doctor. Are you developing models which will look at the Hillsborough River? I have property on the river, which is 2 meter above sea level, and I'm wondering if the risks on the river are more related to sea level rise and storms, or the river flooding is more of a risk?
Well, I guess we will, when we do the flood risk assessment for city of Charlotte, we will certainly have a good sense about what is the major risks for the Hillsborough River area. And because we really need to, I just want to point out, Fahia he asked about stormwater drainage network system, who is a PhD student of mine. So it is him Fahia who is doing this project. So basically, we want to carry out a very comprehensive assessment using the drainage network system, and also we also need to incorporate the sea level rise, different scenarios to help us understand the risks, the flooding risks. So I guess if your property is close to the shoreline, I think the sea level rise plus storm surge during certain storm events, I guess, will be the major contributors to the flooding risks. But if your property is more inland, it's far from the shoreline, I guess the overland flooding might be, the risk of overland flooding might be higher than sea level rise flooding. Yeah, so that's my understanding, but still we need to do a systematic assessment, and after that we can tell exactly what kind of risk you are facing. Yeah.
Yes, and I did get your email. Just now I'm recognizing the name there, Farhan. I did get your email this morning, and I had forwarded on to some people, so hopefully I can get back to you about what you had mentioned about kind of the city's work. I'll wait for another bit, see if there's any more questions, but in the meantime, we do have a survey that we're just asking people to take. It's about probably a minute or two to fill out. I'll just share it in the chat now. It helps us understand how to better understand how we can advertise these types of events. And there's also a section there where you can fill out what you would be interested in seeing as initiatives or projects from the city in the future. So it's definitely something that we highly value, and both the communications and our department will look at and take into consideration. So it's definitely a great way to get your voice heard and just help us spread these kind of initiatives. And if we don't have any more questions, I'll thank you again for your time and giving your presentation and showing us sharing your information and showing those apps to us. And hopefully once that app is available, we can share it with the community. And like again, I said, I will share the recording of this presentation to everyone who registered. But yes, thanks again, and I hope everyone has a great long weekend. Could we send, so there was as part of the registration, there was a email list option. I'll try and send it out through that for everyone who registered for that email list, and hopefully I'll hear as well when it's available and be able to just send that out to you. Is there a last minute question there? Okay, but yeah, I think that's everything. So thanks everyone for coming out, and hopefully you'll be able to make it out next week when we have someone from CBCL, I think maybe messing up that acronym, but talking about kind of more clean infrastructure and how we can manage some of these stormwater issues and climate change concerns on a lot level and more on a community scale. So I'm hoping that's going to be a really interesting talk. So hopefully you can make it out for that. And with that, I'll give it a night. I noticed on the weather app, it was still looking warm out. So hopefully you can go out and enjoy a nice evening walk.
Thank you very much, Alistair. Thank you. Thank you, everyone.